Alright guys, so I'm going to handle some things real quick. This is just a review of properties from Algebra. I want to talk about associative and commutative. Obviously, we have two different ways to do associative and two different ways to do commutative. The first one I want to talk about is commutative, and that's when something changes order. So if you notice here in column A, commutative property of addition and commutative property of multiplication. That's when the stuff changes order. Associative is when we move parentheses. So we're just going to go ahead and do that. And so that's just a real quick look at how we compare the commutative and the associative properties. You guys have had those in algebra. I'm not going to spend a whole lot of time on them. Just remember, commutative is when the stuff changes order. Associative is when the parentheses move. Properties of equality. You used to have a really big graph here. But I just want you to remember there are four properties of equality that are pretty easy. They are addition, subtraction, multiplication, and division. Now, the addition property of equality is basically if I say x minus 7 equals 2, what property are you going to use to solve this? Well, you're going to add 7 on both sides. Subtraction example is x plus 7 minus 2 equals 2. X plus 7 equals 2. You're going to subtract to solve across the equal sign. Multiplication is x divided by 7 equals 2. And division is x times 7 equals 2. Remember, it's not what you're doing to the problem. It's what you have to do to be able to solve for x. Okay? And so, again, just remember equality. You have addition, subtraction, multiplication, division. We also could see substitution. And substitution could be as simple as if I have x plus 4 plus 3 is equal to 2, then you rewrite that as x plus 7 is equal to 2. Anytime you replace something with something else, that is substitution. We also have the reflexive property. So basically, if I say x plus 7 is equal to x plus 7, that's reflexive. We have the symmetric property, which looks a lot like the commutative property. So just make sure you understand a lot of commutative problems are also symmetric. And then we also have the transitive property. And transitive property basically is saying if 2 plus 5 is equal to 4 plus 3, then 4 plus 3 is equal to 7. Or no, I'm sorry, this is and. If 2 plus 5 is equal to 4 plus 3, and 4 plus 3 is equal to 7, then we know 2 plus 5 is equal to 7. That's a really easy example of how to use a transitive property, but you get the idea. So then you have the distributive property. And we know how the distributive property works. We've talked about this before. If I have a letter times information in parentheses, I'm going to take that letter and multiply it to both parts so that I get that when it's said and done. It also works no matter what the sign is. have to distribute it to both parts. And then finally, just like we have reflexive properties of equality, we also have reflexive properties of congruence. And this is when we look at our lines. So if I say line segment AB, and we've been talking about this all semester, that's congruent to line segment AB no matter where I put line segment AB. If I have angle ABC, that's congruent to angle ABC no matter where ABC is in the picture. For symmetry, if I have line segment AB, that is congruent to line segment BA. And we've talked about how that works out. For angle, if I have angle ABC, it's going to be congruent to angle CBA. And then finally, for transitive, basically, if I say that AB is congruent to CD, and then I say CD is congruent to EF, what automatically has to be true? Well, line segment AB has to be congruent to line segment EF. Okay. So we're going to use all this information to do what we call writing a two-column proof. And so in a two-column proof, we're always given something, and we have to prove something. And so I'm going to draw a picture here, and we're going to look at the picture and then prove something to be true. And my picture's not to scale, so don't get excited about that. But given that AB is congruent to CD, we need to prove that AC is congruent to BD. Okay? So here's how it works. We create a two-column proof. And basically, this is a T-chart. On the left, we put our statement. And on the right, we put our reason. And every statement, or every two-column proof is going to start with a given. So we're going to just copy what they told us above. It's our first step. And our first reason is going to be given. Now, in order for this to work, usually you have to add two things or one thing or whatever. And so we're going to add the next step. And I'm going to go ahead and give it to you. What property from above do you think I used to prove that? I did. I used the reflexive property. So BC is always going to be congruent to itself no matter what. So now, the third thing that we're going to say is that AB plus BC is congruent to BC plus CD. Okay? And believe it or not, how many steps have we been through? It's our third step. This is the transitive property. Because it's basically saying if this is true and this is true, then this has to be true. And so then finally, we come up with the end, and that's the important part here. AC is congruent to BD, and now we've proven it. So we've given ourselves two additional steps to help us solve the problem. And that's how you write a two-column proof. In today's classwork, you're going to spend some time using the properties. Now, they're a little bit easier because they're more math properties, and we'll get into some, but they've added a whole bunch of steps, but it's just going to give you guys practice at writing two-column proofs. When we get into chapter 3 and 4, or unit 3 and 4, you're going to see two-column proofs come up a lot more. And so, again, just remember, every proof starts with given, and you're usually given the statement. Every proof ends with prove, and you're usually given a statement to end with. And so then you have to add two things and then pick which property makes that true. Okay? Also, you get a chance on the quiz and the test. There are some looks at the properties. Make sure you guys understand those. Any other questions, see me and we'll talk about the properties, and we'll also talk about and practice another proof if you'd like to ahead of class. Thanks, guys.